Hello everyone. Today we will talk about scalable front-end applications and partially about micro-frontends. And surprisingly, it's a still hot and uncovered topic. My name is Kyrylo Aistrakhanov. I am engineering manager in Parimatch Tech, and we faced a lot of challenges with scaling our application. This because of we got a lot of different regions, a lot of different brands, and we try to provide a modular platform to be sustainable, to be flexible, and provide more and more and more features. So based on that, we got scaling each quarter. So we got new and new developers, new teams, and we try to build the effective development lifecycle without falling to development hell. So let's start from the very basics. When I say it about micro frontend, what do you imagine? I bet you think about microservices as well. And you are correct, it's the same architectural approach, but micro frontends is not about just copying the backend approaches to build things. It's just an evolution of our technical solutions and our technical approaches. Just backend engineers face this issue a little bit earlier than the frontend colleagues. Yeah, so the microservices was built around sustainability to provide fastest life cycle, provides fastest release cycles, and to couple more around business domains and business subdomains. So it's all about the teams and about organizational structures. When we got a large organization with different departments in it, probably it will be logical to provide them independent release and independent development flow, yeah, and then united under one product. So as a Conway Slow said, that when we just designed our technical systems, we are copying our organizational and communicational patterns in our companies. So, as I mentioned before, it's all about scaling and adding new teams, for example, as we do in our company. So we got different teams, and they have all their own environments, Git repositories, and it might be even a mono repository, but we got multi repositories, and they build their own features, and at the end of the day it all united under one Parimatch application and product. So what is a micro frontends? By the definition, what it provides us as a characteristic. So firstly, it's independent releases and deployments. Secondly, it's autonomous development. So we need to provide a possibility for the team to build their features independently from other teams. So it might be based on some contracts, on some mocks or some APIs, but it might be possible to do not couple on some large monoliths and some large architectural legacy systems. And of course, the most important one is for me is just a modeling around business domains and subdomains. So we can call a frontend a micro frontend when it has independent release cycle, autonomous development, and it's all based around some business subdomain or some business domain. Basically, on the top of that, we got an additional characteristic. It's all logical, because when we got an autonomous development, probably the team who developed this product might want their own technical solutions, and it provides us framework agnostic and a technology independent point. Yeah, so probably they have their own familiar tools and their own software development parts of lifecycle. Of course, it can be simply deleted or replaced by other component, so it might be easy to embed. It will provide some level of encapsulation just to prevent breaking something accidentally, because when we live under one environment, it's very easy to break something accidentally if you make something wrong. So we need some level of encapsulation just to prevent that this guy from the department that has 2 months of experience accidentally broke your entire document flow. Yeah? So which benefits of micro frontends do we have? Firstly, it's sustainability. Yeah, so if we will throw away one part of the system, it will not break the entire system. We can just simply remove the one micro frontend from the page, and the entire page will follow work. Yeah, it about fast release cycle. So we can have release each day, literally each day. So we can except Friday. So we can release things very fast, and it all depends on appetites of your company and your product teams. We also got a higher expertise in some business domain or subdomains, because the people works around some domain for the long time. They probably will be perfectly known about this domain. If you go for the some payments team and ask them, which is the most stable API for payment provider in Poland, probably they will answer you, because they know which the API is more stable. They work with it every day. And it provides us autonomous development and little more approaches in the component-oriented testing. So we can test each component independently. So it's also provides us some benefits, so such as contract testing, such as integrational testing, and so on. Okay, so when we face the scaling issue, probably we already have some project that likely shows the spike growth, yeah. And in this point of time, we probably don't want to rewrite entire application from scratch, yeah. So the micro-frontend approach might be iterative. So we might provide a new features without breaking any previous realization. Because no one give you the time, or no one gives, for example, us the time just to rewrite entire application for scratch, and because it's unlogical. The business might work every day. It might give the possibility for clients to get the effort. And firstly, we must think how to not rewrite entire application from scratch. So it might be easy to embed. It might be micro-frontend might be easy to embed. Micro-frontend might be encapsulated just to not break anything. And also we need to think about the performance, because the performance on the client side and the JavaScript is a very pain point for today's world of JavaScript. And it's will be not good if we will move to the micro-frontend approach, and we will provide a lot of overhead for our customers. So we need to think about performance also. So some examples of micro-frontends. As I mentioned before, it's all about business domains and business subdomains. What is business domain? Business domain, in few words, is the effort that you provide to your customer. So for example, if you got e-commerce, your effort to the customers is selling goods. So your main domain is just selling goods. And on the top of inside of it, you might have some different subdomains. So for example, you got a team that provides payment solution, team that provides authorization solution, team that provides recommendation engine for this, and it's all the subdomains. So basic on that, on this, we can build our micro-frontends. So it's mostly any part of application might be a modularized or might be a micro-frontend. It depends on your decomposition and your business subdomains, because the micro-frontends is a subdomain, business subdomain representation on the front end. It must have strict boundaries between these domains. It's not mostly about encapsulating CSS, or JS. Yeah, it's more about encapsulating the business behavior and business domains. So we need to have stable and clean contracts to provide contract testing and independent autonomous development, to provide more easily in autonomous development. And we need to avoid sharing logic with other domains as much as we can. So it's not about sharing the window or the CSS or styles or so on. It's all about decoupling the business domains and decoupling business logic. That our thoughts that we comes to after the 1.5 year of development the micro-frontend architecture. So, and we also need independent release cycle for each micro-frontend, for each our part of application. So it all reminds us of the old familiar for every developer concept. It's all reminds us of the modules. Modules also are independent, self-contained. They do something one and do it perfectly. Yeah, so it's like strict responsibility, simple responsibility. It also specific, so it's maybe have the high cohesion. So if we got different parts of our modules that scoped around same domain, we might just unite it in some repository. Yeah, so if we, for example, got a login and registration, probably the SDK tools, the API calls, and so on will be changed also together. So we need somehow to stick it in the one scope. And it might be reusable, so we can just take one module and work with it as a black box in other part of our application. So this is just a big picture what we want to have. So before we got a sticked and coupled monolith, and then we break it to the different micro-frontends that unites under one shell. Okay, so about the uniting under one shell. In comparison with the microservices, we cannot fully isolate and encapsulate our micro-frontends because they still lives in the same environment. We can encapsulate different parts of it with different level of encapsulation, but as the end, they still use the same user events, the same unique resource identifier. They can share memory, browser cache, and so on. So we need to think more about the trade-offs between the highly isolated modules and the trade-offs with performance and development experience, so on. So when it comes to the orchestrating these models, we got three main strategies how to combine and compile our application to provide the micro-frontend architecture to our customers and to split different teams with different responsibility at the code side. So firstly, the build time composition. When you just create different repositories for the different teams, and they provide simply npm packages that you build it and then you provide it to the front end. It's not true way of making micro-frontends, but it might help you to just split the responsibility in your company. Why it's not true? Because you got a single release point. So when someone provides new version of the npm package, you might rebuild and redeploy entire application. So it's not fully true. So the server-side composition. It's also a perfect place to set your composition because it's fully might be compatible with the server-side rendering, and it provides less overhead and the client side in terms of composition. So the basics is very simple. You got request from the browser and there's some abstraction on the backend. It might be some framework from this one, so it might be Pyral, Mosaic, LC, or so on. Or maybe even Nginx SSI. It's just server side includes functionality from the Nginx that helps us on each request from the user page create a layout with different parts of UI elements in it that may be taken from different hosts and resources. So it's just like one request and the backend tries to recognize, in this part of application we need footer and I can find footer here. In this part of application I need slider and slider I can find there. And it combine all it together on the server side and provide the final result to our customers. And the third part, the most hard to implement, hardest to support maybe, but it provides us incredible level of the flexibility. It's a runtime client-side integration. So it's a self-descriptive, so we got maybe some manifest with the list of models that we want to use. We got some declarative shell that tell us which models that we want to use. And in browser of the user, we just fully decompose and rebuild our application. So it's just got some configs, and based on these configs, in the runtime, the application decides which look it will have. Yeah. So it's like about a fully customizable runtime. And micro-frontends basic suite kit for the runtime integration. Of course, we need some shell that will provide us routing and orchestration. It will provide us some configurations, manifests, and so on. Based on them, we can build our application in the runtime. Of course, we need some modules with maybe render method and mount method. Yeah, if we will try to create it from scratch, and some way of communication between them. So it might be just like a custom realization of some event bus, or it might be like just a similar custom events or post messages and so on. So let's take a look at the basics of the component that might be like a micro-frontend. So as we mentioned before, we do not need couple business subdomains, and it's all about basics of components. So we need some contracts in like a properties, and we need some event passing some event to the top, and it all lives in some integrational layer. Okay, so which models and how we can deliver our models to our customer, how we can create these models with the render and so on methods. Firstly, it might be just a simple JavaScript that just connected to the page. I saw different realization when the people tries to implement their own micro-frontend solution just with EFE pattern, and it was quite good, but it very expensive. I can just imagine how long it takes to create all the possibilities of the micro frontends and this shell routing, sharing dependencies and so on with just simple basic FE and scripts and so on. But it's quite possible. Then we got the modules, then AMD, UMD, and for now we of course got the standard modules and definition, the ES6 modules that we all use, and around it we get different types of build toolings and the systems, such as system.js with import maps, Webpack 5 module federation that I will talk today, and it's just wrappers around the different types of modules with some polyfills and with some custom realization based on the these tools. Okay, so firstly, yeah, just let's challenge a little bit. If you need a micro frontend approach, you just create it with your custom solution. You just need some script with the render method that will provide some markup to your DOM, and you need some CSS that will be loaded, and so on, so on, so on. So it sounds like a plan, yes. So when you just think that, okay, I will just create different scripts with different CSS and different assets, and I will create my custom micro frontend implementation. Just handle some properties from the top, bubble some events, a profit, yeah. Well, if it was 10 years ago, probably it will be looks like this, yeah. So it will be like a different jQuery plugins with coupled that will be coupled around business subdomains, and it will be just simple as this, so just like mount components to the page. But for today we got a lot of more requirements on our products and our business needs. So we use bundles, transpirals, different roads, different frameworks. We need to handle code duplication, version mismatching. We need to provide some encapsulation level and isolation, because we don't want to be something breaking in the production accidentally. So on top of that, we got different approaches that helps us with the runtime integration. It's iframes, module federation, and web components plus ES6 modules. Let's start from the iframes. Iframes provide us a first-class encapsulation, so it's just a king of encapsulation in the web world. So it has its own resource, its own window, but also it provides us some restriction about the access to it, and it provides us a little bit decreasing development experience in providing some events to it and so on. So it's just very isolated encapsulated abstraction, but it provide us additional restrictions, of course, because the stability is the counterpart of the flexibility. So for the terms of deployments and autonomous deployment development, it's a fully independent way to create a micro frontend. So you just have a separate resource into the iframe. So it might be written in any framework with any approaches, and all you need is just to handle events with a post message drawbacks. Firstly, it's a no code duplication control. Even if you use same origin, it will share the browser cache, but it's no way to just reuse, same version of React or same version of Vue and so on. But it's hard to implement. If you have a different origins, it's impossible, I think. So it will load a lot of bundles. If it will load different resources from the different origins. And of course, it's got limited view to render. So if you provide for iframe settings that it might be 60 or 60 pixels in some part of application, and you need to provide some all page pop-up, it will be impossible, because it's not because it's just limited to the view of these pixels. And you need to provide some way to communicate with the shell to provide some possibility. And here we comes to the next part, the module federation part, our favorite part, because it's our particular case. As I mentioned before, we got an issue that we need to scale from the 1 team to 50 to 20 teams when we don't even know how much teams will be, and we need to provide a solution iteratively without rewriting everything from scratch. And luckily we were on Webpack, so we decided to go to the Webpack module federation. Were we prepared for it? Of course not. It was just a very high couplet monolith with different dependencies, with such a complicated dependency graph, and it was hard to implement even decoupling, not even the independent deploys. But we tried, and the module federation helps us a lot with this. So what is a module federation in a few words? Let me take it by the example. I think that everyone works with the lazy loading approach in the Webpack. So everybody face the issue with a lot of JavaScript on the same page, and probably you implementing the lazy loading approach when you split your Webpack application into different chunks and you can load it on demand. So in the previous realization on the Webpack, we can get these chunks only from the same origin. Yes, so if you got a built application with split chunks, you can just load this application parts from the same origin. But with the Webpack 5 model federation, we got a possibility to load different Webpack modules, such as these chunks, from different domains. So you can just bundle and build application with Webpack, deploy it somewhere to the web on some CDN or some S3 assets or anywhere, and you can get it from your current application, such as just Webpack module. So it helps you to load modules just with simple dynamic imports and promises. So it's best fit for teams that already around Webpack. So to provide modularization, it's a very cheap way to provide modularization, and feels like a very native dynamic import. So everybody familiar with the lazy loading, so these native imports of the modules also will be easy to understand. And by default, the module federation doesn't help us and doesn't provide us any level of encapsulation. So we need to handle it by ourselves. The CSS duplication, the error handling, the preventing people from making document equal null and so on. We need to handle it by ourselves with our own lintings and conventions. But on the other side of this coin, we got a flexible solution that we can use with our familiar tools. So let's jump to the module federation basics. As you can see on the screen, the left part consists of the plugin options for our shell, and the right side we consist the configuration for our micro-frontend, that in our particular case is, for example, slides. So let's start from the top to the bottom. So firstly, name is name of the module that might be imported in the another micro-frontend. So by this name we can just write import shell / and then got the internals for that we might expose from micro-frontend. So like if we want to use slides on the shell, we should use, because the name of the micro-frontend is slides and it's exposed slides, we should use import slides / slides. And that's pretty much it. To get our micro-frontend know about each other, we have two options. It's just exposes and remotes. Exposes, you can just expose some modules. It might be any module of that that's supported by the module federation. You can expose it to the entire outer world, and it might be used as the remotes in another micro-frontend. And it also bidirectional, so the module can at the same time expose something and also consume something. For example, for now in shell, we just expose some shell utilities that we consume in slides, but at the same time we consume the slides in our shell. So it's pretty much it. Okay, so the first entity and the first basic part of the module federation is the remote entry. If you will take a look at the Webpack configuration, at the Webpack documentation, you will notice that there are following approach that in the remote parts, when you declare which remote module you need to load, you declare some file that calls remote entry by default. And what is this file means? So it's not a directly module of the remote micro-frontend. It's just a container with dependencies. So for example, we got a slides and we got a remote entry as a file name for this dependency container. And when we should load it on our shell, we will get the possibility to get the slides module that exposed in our slides micro-frontend, exposed from the Windows scope. So it provides us possibility to get links to the dependency, to the modules, through some window and through some Webpack globals. So it's not a dependency itself, it's just a dynamic container with dependency that stores the links to these chunks and these modules. So based on that, you probably never want to cache it for the long time, because you need to invalidate it every time that when you got the release. So how we can achieve the code duplication avoiding with the model federation? It's a very important feature of the model federation. It's very flexible. So firstly, when we need to share some code with the micro frontend and the shell itself, we need to provide it as a shared option in our model federation plugin. So default strategy is fully based on semantic versioning. So if you got a micro frontend A and micro frontend B and the shell, and they all provides as a shared dependency, for example, React, they will be loaded based on the semantic versioning. So the higher compatible version will be loaded and will be used by other micro frontends. If, for example, one micro frontends need a React that, for example, 17 version, and another micro frontend use a 16 version, it will be load the both. Yes, so it will load the both. So which additional possibilities we have? The documentation of Webpack not straightforward about it, so I should take a look at some examples and some combinations. So when you need, for example, only one instance of the library at the page, you can just provide option a singleton true. It has one specific scenario. So if you provide a singleton true, for example, version of the library 1.2, and the micro frontend that will load later will need the breaking changes. They will need the higher measure version, for example 2.4. It will be loaded and it will be used just the previous version from the shell. So it will be used the lower version because it provided as a singleton, even if the micro frontend need the version higher. So it will not load the higher version of the dependency for micro frontend. It will be overridden by the singleton version provided in shell that will load first. And in the runtime, we will see the warning. So the Webpack should try to tell us, come on, you got different versions. If we want to be this not just the warnings but the errors, we need to provide the option strict version true. If we know that, for example, we can use different versions of this package, we can provide the required version and provide the range of version which we need to use in this particular case. Also, we got an option eager true. It helps us to build our dependencies inside the bundle instead of making a synchronous request. So how we can avoid version and developments hell with deployment dependency hell with our shell approach? As we do in our project, we just overwrite all the dependencies with evergreen highest compatible version from the shell. So we got singleton, we got strict and required version in the shell just to overwrite all the shared dependencies in all our remote micro frontends. And the shell are responsible, of course, for the initializing event bus and the routing, self-deprecation of unused APIs. So we, for example, we got a breaking change in the application dependency. We need somehow to deprecate it, and we use self-deprecation with updating it in the shell. So, okay, let's go further. By default, you need to provide all the options with the all remotes in your Webpack config, but it has one ugly pitfall. It will try to load all the micro frontend remote entry and all remote containers by the start of application. So if you, for example, have 50 modules, it might be a problem because it will provide the 50 additional requests and start of application. So we need somehow to load this dynamically. And of course, we cannot even know how much micro frontends will be in the future there. So for this, we can use that just dynamic remote entry loader that there's simply a script. So the remote entry container is just simply a script. So we can just load it. After it will be loaded and executed, we will get a container with dependencies in the window. So we can use it, and around this we can create a utility function that will load remote module. It handles two properties, the scope and module, and it will try to get our module from the window scope after the container will be loaded. So it pretty much it. And it also compatible because it's like dynamic import. It provides us just a module, and we can wrap it in a async function. It's also compatible with all the loadable or React lazy or additional tooling that helps us to make dynamic imports. And we can use it is, for example, in React with error boundary, with some fallback, and provide it as a just simple component. So this is how we avoid the CLS and just cumulative layout shift. So we provide also in the shell fallback with the skeletons. So while we load our micro frontend, it will show skeleton. And also we wrapped it all in error boundary. And error boundary is just our custom realization because it provides handles some scope. It's just a component did catch lifecycle hook in React that helps us to catch errors in some components. So on this part of component did catch, we didn't make any additional logic. It's just a wrapper around our logger. So here we just can check in which Crashlytics we will send this or that, in which shell we can use different Crashlytics. So error boundary is just a wrapper for us around our logger and around our Crashlytics tools. So for now we use Sentry, but lately we might use some Elastic APM, for example. Okay, so we need to provide scope with the team and component and location where the declared component just to helps us to check the health of our application. So we can open the, for example, Sentry dashboard and show that, oh, we got a lot of errors with some team, or we got a lot of errors with some components in this location. So it helps us to see what's the problems our product have. So the site isolation, it's also in model federation doesn't provide any way of encapsulation by default. So we need to handle it somehow with our way. You can handle with it with some specification and conventions such as BEM, or you can use, as you I think all do, CSS in JS, but that is simple additional topic that also we need to prevent some additional salt for each hash that will generated in such MFE, just to prevent their collisions. Okay, so cross-component communication with model federation is very straightforward. We don't have any restrictions to use only custom events or only post messages, so we can use our custom event bus. In our case, we got an RxJS based event bus, event emitter, because we like the push-based approach. So we just, if you're not familiar with RxJS, it's just a library that provides us reactive functional way of programming. So we just can create flow of events from any source and then pipe on it like with some functional operators. And it's very simple and straightforward. So for our event bus, it helps us to handle one minor inconvenience. So for example, let's assume that we got a provider of data that provides us, for example, information about user, and it loads first on the application, and in common scenarios with the pool-based architecture and event-driven design, it will fire that, oh, I'm loaded and I have this information about user, yeah, and after the another component will load on the page, he didn't notice that this event was fired, and it will provide additional needs to create more events just to send, hey, get me, please provide me information about data. And this component, after he will connect lately, need additional request the data. With the push-based approach, it seems different. For example, we can just connect different components on page, and if the first component will emit some value in the our Rx bus, the next component that will attach to the DOM, if he will need the data from this topic, he will get the last value. How we can achieve that? We use the behavior subject from RxJS. So it simply stores the last value that had been emitted into the topic. What we call the topics. Topics is just naming of our events. So we got, for example, user data updated or user data received, and it's just the topics. When we emit something in around our Rx bus, it provides a behavior subject on this topic, and we can use it as Rx bus on some event or Rx bus emit some event, and it will provide us a push-based approach to handle the changes. Of course, when we got different subdomains in different teams, we need somehow to control that they didn't have collisions in their logic and their data providers. So if you got one user data provider, it might be only one data user provider. We cannot have different elements in the page that provides user data, because it will be a collision, it will be not a good case. So we provide basic tooling and contracts control based on our custom ESLint plugin. For this we use a centralized event schema that provides for our ESLint plugin information about in which parts of our application, which topics with which prefix we can use. If you get a monorepo, it might be even easier, but with multi-repo we need another standalone S3 assets storage. So for the deployments with model federation and fully independent, even if each team has its own CI/CD, at the end of the day it's all only about the static. So we can just deploy our static to our static storages, to the S3 for example, or also we can deploy it somewhere to the npm, of course. So that's pretty much it. So you just have different teams and different repositories, and they all deploy the static to S3, and then somehow on the infra and engines we can just send the needed micro-frontends. Which additional possibility do we have? Versioning. If we use semantic release, we use semantic release in our micro-frontends, it will provide the possibility to create buckets and to create folders with version. So we can get the version from our client-side integration. On demand we can get some version that we need. Of course, it might also be realized with some npm packages, with some CDN that will act like our buckets, but it will be provided from the CDN, and it will provide npm packages, because at the end of the day, as I mentioned before, it's all just about static. So how we can just send the proper version from the browser to get it from the assets? Of course, with dynamically remote paths that we mentioned before. So you can just generate different remote entries with different versions, and because we got fully client-side orchestration strategy, we can probably even send the remote config with the list even of versions which we want to use in our application. So it might looks like JSON file with different descriptions that on this page we need to use, for example, slides version 0.0, yeah, and it will generate automatically remote entry and should try to get the version with current micro-front with current version. So it provides us a higher level of configurability, so it's all based on the runtime configs and the remote JSONs. So we just can feature, toggle everything. For the testing, it also impacts our testing, because it's micro-frontends, it doesn't only about the front-end approach, it's about software development lifecycle around all the companies. So we need to provide more control around different asynchronous releases. Yeah, so we need to handle all the pyramid of testing in our software development lifecycle to prevent ugly pitfalls at Fwdays. So we need to start from unit, then we got component testing that provide us possibility to test components independently, because each component are fully isolated. We can use it as a separate application and test it also as a separate application, because it's all based on the coming properties and bubble some events. So we can mock something, we can test the component in black box in the separate environment, and then on top of this we need the integration test and regression test. Of course, what might be also wrong? Yeah, so we might change and break our performance metrics, and the performance culture in the asynchronous teams might be a little bit lacking. So we need to provide some way of control of the dependency of the performance on each micro-frontend that we have, because we cannot trust that someone from another part of the company doesn't set additional 2 megabytes of icons in our bundle. Yeah, so we need somehow to control it. If you started your development lifecycle, it will be perfect to set the performance budgets from the very start, from the very beginning. For this approach, we can use SiteSpeed Grafana, web page test Grafana, Lighthouse Air, or any other tool that you're familiar with. If you have a pleasure to impact on the software development life cycles in the macro frontend itself, it'd be good to provide the Webpack bundle size also to check the bundle of the each macro frontend. So for the caching, there's nothing special because Webpack bundles we just use the hashes and infrastructure cache control with the CDNs and Cloudflare, for of course. Service worker based cache for different types of statics, so it's like images, SVGs, PNGs, and so on. And we also use YTags. So YTags are very useful for remote entry invalidation. Remote entry, as by default, doesn't have different hash invalidation. So and it might be very complicated to invalidate the dependency container remote entry after each release. You need to just couple a lot of CI/CD pipelines just to change the hash, then you need to change it on the manifest for the runtime client, so we use the YTags. YTags also very nice approach. So the amount of requests might be a trouble because we got a lot of different modules that all resolve their own dependency and configs by their own requests. It might be a very big trouble because we got a lot of additional requests. So cache it and reuse. So what's about the Frankenstein with different frameworks of page? It might be created with a module federation, but of course it will provide it will be necessary to add some wrappers around it, so you just cannot use different frameworks and Webpack modules in the terms in one application. So you need some framework agnostic shell that will just unite all these parts of application together, but you cannot, for example, insert React into Angular. Yeah. Okay, so conclusions about module federation. It's good for teams that already on Webpack. It's highly flexible and very natively feels in the way of development experience, and it doesn't provide a lot of encapsulation by default, but you can just simply handle it with the conventions or some linting rules, and it's very good way to start the modularization project if you got a Webpack application. So for everything else, there are web components and ES6 modules, so it's more closer to standards. It provides a high level of encapsulation. Web components consist of ES6 module, custom elements, shadow DOM. I think you all heard about and familiar with it. So the custom elements is just a custom HTML tag that we can relate, that we can use, and it also uses the shadow DOM to encapsulate some CSS and behavior internal. So it will also possible to create a Frankenstein with different frameworks on the same page. It's just a wrapper that I mentioned before, so we just need to define custom element, create some div with component, and then just when we got our application mounted as a web component to the main page, we just load and insert our application with written on React or on the Vue on Angular in this part of page. So the few words about web components and how we use them. We use the web components to write our UI kits and implement design system, but the main drawbacks for now for us is the server-side rendering. Development experience is pretty good because it's a lot of micro frameworks around it, and it feels like natively React or some other frameworks development. Deployments is just also simple static. Encapsulation, it's on the medium level, so it's like perfect balance, and it's easy embed of any page because custom elements is just HTML text. Yeah, for some frameworks such as React, you still need a wrapper because they don't support fully custom elements by default. But it's wrapper, it's quite light. So in the communication, we can provide with custom events. So conclusion: just for us, it's a long-term bet on the web standards. We're waiting for the SSR possibilities. Okay, so as a conclusion, I think we got a overview about around all the approaches that we can build the micro frontend in the runtime composition. And for now we got more than 15 teams with fully freedom for teams and developers. It's provide less cognitive load, so it's easy to onboard newcomers. We improve our development life cycles, we increased our release cycles, so for now we got releases each day except Friday, of course. And for sustainability, we got 1.5 years in the production with the current approach, so it's quite good. And then the final words, I want to say that micro frontends, it's just an approach that more likely about the scaling teams and the philosophy of the compositions on the different business subdomains and domains, rather than way of encapsulate your styles or encapsulate your behavior. So it's all based around basics of software engineering. So it's all about low coupling, high cohesion, and it's all about the best practices of keeping your modules self-descriptive, self-independent, and provide a flexible way to provide the features for your customers. So thank you all for attention. I hope you're well. I hope you're safe, and not release anything on Friday. Thank you. Have a nice day.
Thank you for your presentation. We have a couple of minutes for live Q&A session, and to our audience, please post any question in Discord or Telegram. In Discord, it's track B. So far, I have a couple of questions. You mentioned about the different teams that can basically work on different models. So it's everything is model, everything can be done in parallel. I'm wondering who is responsible for kind of main layout, who's responsible for bundling everything together, and is there a chance with updating layout to break something? I mean, yeah.
Yeah, so the main responsibility for the layout and the first attempts of implementation of this type of architecture was the team that we called like integration team. So integration team was acts like a platform team that helps people just to use their micro-frontends in the main layout. But then we just follow the conventions. So we got strict cookbook how to add the new micro-frontend into layout. So it depends on different brands and different teams. We got the code base shared between different regions, and there have different layouts that fully composable with the feature flags. So for example, if you got a layout, you provide the feature flag around it. So we all feature flag based architecture. So if you need some type of layout, you add a layout, you compose it as you like, you hide everything around behind the feature flags. And the team who made it is responsible for it. Basically, it's just like product request that for some product, we need different composition on the page. And who implements it on current product, then it's his responsibility.
Okay, sounds great. And another probably similar question regarding to the experiments. You mentioned that, yeah, basically you are a feature flags company, and you are doing a lot of A/B testing. I'm wondering, are there any challenges on running A/B test in multiple models at once? What it takes basically? Do someone need to involve all the teams to kind of add these flags, or how it works?
Yeah. It's a problem, not technical level. So it's not we cannot handle it on the technical level. So it's mostly about communication between our growth team. Of course, if we got two different teams that simultaneously run same A/B test, maybe they just have some collision in their results. So it all depends on them, and I think they communicate one each other when they started to implement some A/B test. But yes, it's of course it's also an issue. Yeah, also an issue.
Okay, thank you. And probably the last question. You mentioned testing. There was only one slide about testing. I'm wondering how integration testing works. So basically, some team develops the model. Should this team to kind of somehow check that it not breaks the integration? If yes, how this checked basically? What's the environment? What approaches?
Yeah, so we got straightforward way for testing on different environments. We got two environments: it's stage and production. So stages are different by different products. So each product has its own stage, and when someone release new model, it probably need to cover it with some basic user test based on feature, because it's all stick to the feature. Even one model, it might be separate feature, and it all written by the test cases written by the not integration team. It's just like a feature team who develop it. They just provide the tests for running this part of application, and it part of the CI/CD pipelines. So development team produce some feature. They're also in the integrational layer where they will use this feature. So on this particular brand. And all to not couple on their quality gates, we got an integrational test that acts like just critical user path, just to check that main functionality of the application is working. So it's like login, registration, and so on. And it's like high critical testing, and it running almost every time when we deploy application, and probably even different models on this product stage. And it's like a high quality smoke testing that everything just pass properly. So it's like health check. And we got additional requirements for quality gates for the teams who developed separate features. So we cannot run all the features, all the tests for all the parts of application every time when we deploy one of our 15 models. So for that, we just can handle it with some downstream pipeline, have quality gates from this team. We might check that they are working properly. But in health checks, that to
have some connection issues. Okay.
Hello.
Yeah, go ahead.
Yeah, so basic integration tests with high critical priority, with the basics health check about different main parts of application running every time when we deploy a new model. But we also had additional quality gates for the feature teams that develop their own models and their own tests. And it might be started on demand, so we don't need it to run it every time.
Makes sense. So, sounds like a great approach. The super last question: are there any guidelines on how to detect is it a breaking change or not? Are there any automation for kind of detecting breaking changes?
Breaking changes in the dependencies
I mean,
in
models. Yeah, you mentioned that there could be some different version. If it's breaking change, then probably someone should bump the major version. So how this works? So is it just a decision of developer, or there are some automation?
It's a decision of developer. I know that nobody likes the semantic versioning, but we try to implement it. So we got a convention: if you got breaking change, just wrap it to the soft deprecation, write some code that this method will be deleted, and then just you get some stable time to adopt everyone on it. But of course, they only want to handle this type of breaking changes. If someone bumps version in the shell and broke the behavior of other models, it's also just stage tests and integration tests.
Okay, makes sense. Thank you. We run out of time, so now we're going to switch to voice chat in Discord. And for audience, we're going to have a break, and after which we meet the final talk of full stack components by Hans Dots. Thank you. Thank you, Kyrylo, for a great presentation.
Thank you. Have a nice day. Bye-bye.